The morning of June 2nd, 1944, the sun had barely risen over the Yokosuka Naval Arsenal. Steam rose from the massive slipways like the breath of a sleeping giant, casting pale light on the steel skeleton of a new carrier under construction. Engineers and labourers moved between scaffolding like ants on a cathedral-sized nest. At the heart of the chaos stood Captain Masayuki Tanaka, inspector for the Imperial Navy, clipboard in hand, eyes tracing the unfinished hull of what was meant to be Japan's answer to the Essex-class carriers that had begun dominating the Pacific. Tanaka's heart was heavy with anticipation and unease. Reports had arrived from intelligence officers. The Americans were launching a new carrier, USS Essex, with flight deck elevators so massive they could lift a fully loaded bomber the size of Japan's heaviest torpedo plane in a single motion. 5,000 tons of lifting capacity, engineers had calculated. 5,000 tons. It was an idea so audacious, so foreign to Japanese design philosophy that it seemed almost fictional. Yet photographs and schematics, smuggled through Shanghai, had confirmed it. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The Japanese naval doctrine, built on the decisive battle theory and years of meticulous carrier engineering, had always emphasized speed, agility, and concentrated striking power. Every carrier was a precise instrument, every elevator, catapult, and hangar designed to balance weight, speed, and structural limits. Tanaka and his colleagues had believed that incremental improvements reinforced flight decks, faster catapults, slightly larger hangars would allow them to compete with American designs. Now, faced with the sheer scale of the Essex's elevators, that belief began to waver. By 1944, Japan's Pacific situation was dire. Pearl Harbor had been 2.5 years in the past. Midway had shattered the veteran core of their carrier pilots. The Solomon Islands campaign had bled both men and material. Each fleet carrier they could produce now had to compensate for losses in experience, training, and numbers. In contrast, the United States was producing Essex-class carriers in less than 2 years per vessel, each able to carry 90 to 100 aircraft, supported by hundreds of trained pilots cycling through a rigorous 6-month training program. Japan's Unru-class carriers, intended as simplified substitutes, still required 4 years to complete, and even then, lacked the air groups and logistics to match the Americans. In Yokosuka, the Imperial engineers were working on the hull of what they had hoped would be Japan's new supercarrier. The design, initially called Shinshu, was intended to incorporate lessons from Midway and the Solomons. Engineers planned for a larger hangar, deck, reinforced elevators, and a heavier armor scheme that could withstand a 500-pound bomb hit. Calculations had been made for engines producing 160,000 shaft horsepower, enough to push the ship past 30 knots. Tanaka walked the flight deck mock-up, running his hands along the steel railing. Every weld, every deck plate was a testament to ambition and hubris. His notes from the American schematics lay in his pocket. The elevator design alone would require machinery and foundations that exceeded any crane or structural support Japan had ever built. 5,000 tons. To lift the heaviest torpedo bomber fully fueled and armed, the Americans had engineered massive hydraulic systems, catwalk networks, and steel plating thicker than a battleship deck. Japanese engineers tried to calculate the stress tolerances. "It will never float," one muttered to his foreman. Another countered, "Perhaps, if we abandon the armoured flight deck entirely, reduce aircraft, complement by half, we might." But each suggestion was met with a long silence. Unlike American shipyards, where standardization and assembly line methods allowed dozens of carriers to emerge with mechanical precision, Japan's yards were fragmented, each ship essentially a one-off. Every large modification required redesign, retraining, and months of testing. By July, the crew of planners and naval architects realized the unthinkable. To replicate the Essex-class elevators, Japan would have to construct machinery bigger than any single hangar deck, heavier than entire sections of their Yamato-class battleships, and reinforce the hull beyond feasible limits. The weight alone would compromise speed. The cost in steel and manpower, already stretched thin by the war in the Philippines and the ongoing defense of the Marianas, would render the project impossible. It was not just the elevators. The Americans had integrated their carrier systems in ways Japan had never attempted. Flight operations were synchronized with elevator cycles, hangar storage, and maintenance schedules in a carefully choreographed system. On an Essex, a fully loaded dive bomber could be launched, recovered, refueled, rearmed, and relaunched within 90 minutes. Japan's carriers required at least twice that time, even with veteran crews. To copy the Americans fully, the Imperial Navy would have had to rethink everything about carrier operations, ship architecture, flight deck engineering, pilot training, and even supply chains. And so, in the sweltering heat of Yokosuka, amid the hissing of steam and the clang of steel, the Japanese design team made the bitter decision. The supercarrier would never be completed as planned. Instead, plans were scaled back. Elevators would remain smaller, hangars narrower, and aircraft complements limited. The ambition to match the Essex in size and capability was abandoned not for lack of skill, but for the stark, material reality of American industrial power. The irony was almost palpable. Japan, which had once sought to strike fear into the Pacific with swift, precise carrier attacks, now confronted the tangible manifestation of a different kind of naval dominance, one built not on daring maneuvers or elite pilot skill, but on sheer, unrelenting production, engineering audacity, and standardization. By the summer of 1944, American carriers, 24 ships of the Essex-class and counting, would dwarf and outproduce Japan's entire carrier fleet, an industrial rhythm that no amount of Japanese ingenuity could match. For Tanaka, standing on the half-completed flight deck, the realization was bitter. The Americans had redefined the rules of carrier warfare, and Japan's best response was not innovation, but retreat from ambition. The elevators were not just steel and hydraulics, they were a symbol of an unbridgeable gap. 5,000 tons of capability, 5,000 tons of inevitability. By late July 1944, the Japanese naval architects had gathered in Yokosuka's main design hall. Blueprints, sketches, and American schematics covered the walls. Tanaka, now joined by Lieutenant Commander Hiroshi Sakurai, paced the room, muttering calculations under his breath. The elevator issue loomed largest among all design challenges. It was not merely a question of lifting capacity, it was a problem of stress distribution, mechanical reliability, and ship stability. The Essex-class elevators were effectively mini floating docks. Each platform could lift 30-ton aircraft fully loaded with bombs, torpedoes, and fuel. The mechanics required hydraulic rams, counterweights, and steel girders, whose combined weight exceeded 5,000 tons. Japan's heaviest ships, the Yamato-class battleships, had hull sections that could barely bear that weight when concentrated in a single area. Integrating a 5,000-ton elevator into a carrier-sized hull was a problem engineers had never faced. Every calculation revealed the same conclusion. Either the ship would become dangerously top-heavy, or speed would fall below the 28-knot threshold necessary for flight operations. Efforts to find workarounds became increasingly desperate. Sakurai proposed dividing the elevator into multiple smaller lifts, each handling a portion of the aircraft load. We could stagger operations, he suggested. Perhaps launch 2 or 3 bombers at a time instead of the entire flight group. But the proposal faltered immediately when Tanaka ran through the flight deck timing. Launch cycles would double, maybe triple. A strike force intended to deliver 60 aircraft in under 90 minutes would now take 3 hours. By the time Japanese air groups could reach their targets, American fighters, guided by radar and coordinated from Essex-class decks, would already have established air superiority. Attempts to reinforce the hull required steel beyond Yokosuka's production capacity. Japanese steel output in 1944 was constrained by Allied submarine attacks, raw material shortages, and repeated bombing of industrial centers. Each ton of steel diverted to carrier reinforcement was a ton not available for anti-aircraft guns, ammunition, or coastal defenses. The engineers realized that even if construction of the elevators were possible, It would sap resources from every other critical program, from submarines to aircraft production. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The psychological impact on the naval staff was immediate. Japanese naval doctrine had long emphasized daring, audacity, and ingenuity. Decisive battle theory demanded that skill and timing could offset numerical disadvantage. Yet here, the problem was industrial, not tactical. No amount of clever engineering or pilot heroics could overcome the sheer disparity in production capability. For the first time, Japanese planners were forced to confront an inconvenient truth. The United States had created a system of carrier warfare that could not be matched by imitation alone. Tanaka recorded his observations meticulously. Even a minimal replication, he wrote in his log, requires resources greater than any single fleet possesses. To construct a 5,000-ton elevator, we must redistribute steel from coastal defense and aircraft production. The cost of parity exceeds operational capacity. The concept is untenable. By August, prototypes were tested, though none approached American dimensions. Yokosuka engineers constructed a model elevator capable of lifting 12-ton aircraft, essentially the weight of a Mitsubishi G4M Betty bomber, fully armed. Tests revealed catastrophic problems. Hydraulic pistons buckled under repeated load, counterweights cracked steel support beams, and vibration during operation threatened the entire deck structure. Even temporary suspension of flight operations became necessary to prevent structural damage. The psychological toll on the design teams was matched by that on operational planners. Pilots, many of them veterans of the Solomon campaigns, were briefed on the carrier's limitations. Flight exercises revealed that even with smaller elevators, sortie rates were insufficient to challenge American task forces. Lieutenant Commander Ichiro Matsuda, assigned to oversee air operations aboard the prototype, noted in his diary, "We are attempting to match them with half their power. Any engagement against an Essex-class group is already preordained in outcome." The Imperial Navy attempted further workarounds. Catapult power was increased, hangar layouts were reconfigured, and aircraft lifts were staggered to allow partial operations. Yet every adjustment came at a cost. The flight deck became more congested, aircraft maintenance suffered, and the risk of operational accidents grew. Each new innovation only reinforced a single conclusion. The Essex-class carrier represented a fundamentally different philosophy of naval engineering, one Japan could not duplicate under wartime constraints. Meanwhile, intelligence reports confirmed the Americans were deploying additional Essex-class carriers across the Pacific. By September, task forces included up to 14 operational carriers, each capable of carrying 90 to 100 aircraft with trained aircrews. Japanese planners watched the expansion in disbelief. Even if the prototype carrier could be completed, it would be a single ship against a task force of a dozen. Any engagement would be asymmetrical from the outset. The engineers' diaries reveal the quiet despair of this period. One entry, written by a senior mechanical officer, reads, "The Americans have solved what we could only dream of. Elevators of 5,000 tons, launch rates unimaginable. We labor for weeks, for months, only to discover that the system itself is beyond replication. The magnitude of their industrial power cannot be matched." In October, construction on the supercarrier was officially curtailed. The Japanese Navy ordered a reduction in elevator size, simplification of the hangar deck, and elimination of secondary systems deemed non-essential. The vessel was renamed Shinryu II and reclassified as a light fleet carrier, capable of only 50 aircraft. Even this reduced design required full-scale testing, as stability remained marginal and speed compromised. The abandonment of the Essex copy project had far-reaching consequences. Japan's naval planners, already constrained by shortages of trained pilots and aircraft, faced an impossible operational scenario. Deploy fewer planes, slower flight cycles, and inadequate deck support against a rapidly expanding American carrier fleet. The psychological blow was profound. Veteran admirals, long accustomed to leveraging tactical brilliance to offset numerical disadvantage, began to accept that industrial output was now the decisive factor. By November, Japanese officers openly acknowledged the futility of trying to match the Essex-class directly. In internal correspondence, Rear Admiral Keiji Shibasaki wrote, "No single design, no matter how ingeniously conceived, can overcome the output and integrated efficiency of the United States. Our efforts to replicate are gestures, not solutions." The story of the 5,000-ton elevators became something of a cautionary tale within naval circles. Officers would later recall the day schematics arrived from America, a mechanical impossibility in the Japanese context, a symbol of a strategic gap that could not be closed through skill or daring. The Essex-class did not merely outmatch Japan in hardware, it shifted the very calculus of naval warfare. Japan's carriers, once the epitome of precision and lethal efficiency, now faced an enemy whose mass production, philosophy, standardized engineering, and integrated operational systems rendered imitation insufficient. By early 1945, as the Marianas, the Philippines, and Iwo Jima fell under American air power, the lesson of the abandoned elevators had crystallized. The Japanese Navy would never regain parity at sea. Smaller carriers, reduced air complements, and limited deck systems meant that even the most audacious operations could not prevent the erosion of strategic initiative. Every sortie became a gamble, every engagement against the American fleet an exercise in survival rather than victory. The psychological and operational ramifications extended beyond technical limits. Pilots, engineers, and admirals internalized the disparity in industrial capacity as a central truth of the Pacific War. Unlike in 1941 or 1942, when audacity and tactical acumen could deliver disproportionate results, by 1944 the balance had shifted. Japanese naval doctrine, and rooted in decisive engagement theory, confronted the reality of Essex-class mass production. Control of the sea was now inseparable from control of industry. And yet, the human story endured. Engineers and officers persisted in testing, adjusting, and innovating within impossible constraints. Flight trials continued aboard the reduced carrier. Sorties were flown under the careful supervision of Lieutenant Commander Matsuda, and the vessel itself, though a shadow of the Essex-class, remained a testament to ingenuity under limitation. In these efforts, the subtle irony was inescapable. Japan had the technical skill to design a supercarrier, but lacked the industrial backbone to realize it. Every calculation, every prototype, every adjustment only underscored the dominance of American design philosophy, not its complexity. By December 1944, the Shinryu II, reduced to a light fleet carrier, was finally launched. The hull slid into Tokyo Bay with a ceremonial splash, accompanied by the low hum of a workforce exhausted by months of labor. Yet the celebrations were muted. Officers and engineers alike understood that the ship represented compromise, not triumph. It embodied ambition curtailed by reality, a vessel born of aspiration, but limited by the material and industrial constraints Japan could no longer overcome. The psychological consequences of the aborted Essex replication were profound. Japanese naval planners, long accustomed to relying on tactical ingenuity and elite crews to offset numerical disadvantages, were forced to confront a strategic paradigm they could not control. The war had evolved from one of daring engagements into one defined by production, redundancy, and endurance. Aircraft carriers were no longer simply platforms for striking force. They had become symbols of industrial supremacy. The Shinryu II's elevators, now smaller than the original design, could lift only a fraction of the intended aircraft. Flight operations were slower, maintenance cycles longer, and sortie rates limited. In exercises, a strike group of 30 aircraft took nearly 2 hours to prepare, refuel, arm, and launch, less than half the efficiency of an Essex-class carrier's 90-aircraft complement. Radar and communication systems were outdated, providing minimal situational awareness compared to American carriers' integrated sensor networks. The contrast was stark and demoralizing for pilots and crew, who had once trained with confidence in the precision and effectiveness of Japanese carrier operations. Training programs revealed additional limitations, Japan's pilot pipeline, disrupted by the loss of veterans at Midway, the Solomons, and eastern New Guinea, could not keep pace with attrition. In comparison, the United States' 6-month training cycle produced fully qualified pilots at a rate tenfold higher than Japan's. Even a technically capable carrier could not overcome a shortage of experienced aviators. Lieutenant Commander Matsuda, who had overseen flight trials, noted in his diary, "No matter how finely engineered the ship, without skilled pilots to fill the cockpits, it remains a skeleton of its potential." The operational reality was further compounded by the strategic situation in the Pacific. By January 1945, the Marianas, the Philippines, and Iwo Jima were within American reach, providing bases for long-range bombing and carrier strike operations. Task forces consisting of 14 to 17 Essex-class carriers could maintain continuous flight operations over vast distances, launching waves of up to 500 aircraft in coordinated strikes. Japanese carriers, even with full complements, could muster fewer than 100 aircraft in total, and even these were hampered by limited elevators, slower launch cycles, and inadequate repair facilities. The irony of the 5,000-ton elevators became emblematic within naval circles. American industrial engineering had created a force multiplier so profound that Japan's finest designs could not hope to replicate it. The massive lifts, hydraulics, and steel support systems of the Essex-class were not merely technical marvels. They represented a philosophy of naval warfare in which mass production, redundancy, and integrated operational planning outweighed individual skill or ingenuity. Historians later reflected on the significance of this moment. The Japanese Navy's attempt to copy the Essex-class highlighted a fundamental shift in 20th-century warfare. Victory was increasingly determined by the ability to mobilize national resources at scale. Japan's engineers could innovate, but without the industrial infrastructure to support their designs, technical excellence alone could not ensure success. The 5,000-ton elevators were thus both a literal and symbolic measure of the gap between aspiration and reality. In operational terms, the consequences were immediate. By February 1945, Shinryu II participated in defensive exercises near the Japanese home islands. Launching drills demonstrated the limitations anticipated months earlier. A strike wave of 20 aircraft required nearly 90 minutes to prepare, while an Essex-class carrier of similar size could launch triple that number in under the same period. Even with experienced pilots, the ship could not contribute meaningfully to fleet defense against American carrier task forces operating hundreds of miles offshore. The story also had human dimensions. Engineers who had labored for months on the original Essex copy project experienced a mixture of pride and frustration. Pride in their technical achievements, reinforced hull sections, novel hydraulic systems, and flight deck innovations, but frustration at the insurmountable limitations imposed by industrial capacity. Officers like Tanaka and Sakurai faced the personal reckoning of understanding that their expertise could not overcome systemic constraints. Their diaries and memoirs, preserved in naval archives, frequently reference the moment the American schematics arrived, a physical, almost tangible reminder of a new scale of naval power. Even in retrospect, the episode carried lessons beyond Japan. Naval historians emphasize that the Essex-class carriers represented a convergence of engineering, training, and logistics. The 5,000-ton elevators were part of an integrated system: rapid aircraft cycling, robust damage control, radar-directed fighter coordination, and standardized maintenance protocols, all combined to create operational superiority. Attempts to isolate a single element, the elevators without replicating the entire system, revealed the impossibility of achieving parity. By March and April 1945, as American carrier groups supported invasions of Iwo Jima and Okinawa, the Shinryu II and its contemporaries remained peripheral. Japanese carrier doctrine, once predicated on decisive engagements, had shifted toward attrition and defensive operations, largely due to limitations in both production and training. The abandoned Essex copy project had foreshadowed this reality. Japan's inability to match American industrial output dictated the operational framework of the war's final year. Reflecting on the episode decades later, naval analysts noted a profound psychological shift. Whereas early war doctrine emphasized initiative, boldness, and technical ingenuity, Japan's leaders increasingly confronted the reality that strategic outcomes were dictated not by individual heroism, but by industrial scale. The failed attempt to replicate Essex-class elevators became a case study in the limits of ambition confronted by material reality. It was not a story of incompetence, but of encountering a paradigm shift so complete that conventional experience offered no guidance. The human element of this story, the engineers, planners, and pilots, remains compelling. Diaries record the quiet despair, the adjustments made to salvage designs, and the incremental innovations that still emerged despite systemic constraints. For example, smaller elevators were improved with faster hydraulic response and reinforced supports, allowing limited surge operations. Flight deck layouts were refined to maximize aircraft movement efficiency. While these efforts could not close the gap with the Essex, they demonstrated ingenuity in constrained circumstances. The strategic legacy was clear. By the summer of 1945, American carrier dominance, anchored by the Essex-class, was overwhelming. Japan's remaining carriers could not contest the Pacific skies effectively, nor could they project power beyond a few hundred miles of the home islands. The abandoned 5,000-ton elevators were emblematic of this larger asymmetry, a technical ambition halted by industrial disparity, a microcosm of the broader imbalance that defined the war's final phase. In the broader context of World War II, the episode illustrates the interplay between engineering, psychology, and strategic reality. The Americans did not simply outfight Japan, they outproduced, out-engineered, and out-coordinated them. The 5,000-ton elevators were not a weapon themselves, but they symbolized an integrated approach to warfare that Japan could not emulate. It was an incontrovertible lesson in industrialized conflict. Material resources, standardized systems, and rapid production could outweigh individual valor or tactical ingenuity. The story concludes not with dramatic battle, but with quiet acknowledgement. Tanaka, now a rear admiral in the post-war Japanese maritime self-defense force, would later write, "The Americans taught us a lesson in scale and coordination. We could design marvels, but without capacity to realize them, they remain aspirations. The Essex elevators were not merely steel, they were a threshold we could not cross." The Shinryu II, reduced, imperfect, and never able to match its inspiration, remained a testament to that lesson. It sailed, it launched aircraft, it trained crews, but it never altered the course of the war. In the shadows of the Essex-class carriers that now dominated the Pacific, it served as a reminder that in modern warfare, the combination of industrial capacity, standardized engineering, and integrated operations often matters more than individual brilliance or daring. And so, the story of Japan's aborted Essex copy, its 5,000-ton elevators never realized, stands as both a technical and human narrative. Ambition confronted by reality, expertise humbled by industrial might, and a psychological shift that redefined how the Imperial Navy understood its place in the war. From Yokosuka to the Marianas, from the slipways to the Pacific battlefronts, the lesson was clear. The future of naval warfare belonged not to the cleverest engineers or the most daring pilots, but to the nation capable of producing, sustaining, and integrating its instruments of war on a scale unmatched by any adversary. By the spring of 1945, the Pacific War had entered its final, relentless phase. Across the islands of Iwo Jima, Okinawa, and the Marianas, American carrier task forces pressed forward with overwhelming strength. The Essex-class carriers, numbering more than a dozen operational vessels, orchestrated continuous air operations, projecting power across hundreds of miles of ocean. Each carrier, with its 90 to 100 aircraft and fully trained aircrew, was a self-contained instrument of war, capable of sustaining operations for days with minimal disruption. In contrast, the Japanese Navy's remaining carriers, light, reduced, and limited in scope, were shadows of their former ambition. The Shinryu II, born of the aborted Essex copy project, represented both ingenuity and limitation. Its smaller elevators, reduced aircraft complement, and fragile flight deck systems made it incapable of matching the Americans in operational tempo. In exercises, flight cycles stretched for hours, sortie rates were low, and maintenance demands exceeded the crew's capacity. What had begun as a bold attempt to rival American engineering ended as a sobering demonstration of disparity. For the engineers and planners who had labored on the Essex-inspired designs, the psychological consequences were profound. They had invested months in calculations, blueprints, and prototypes, driven by ambition and the desire to restore Japan's naval prestige. When confronted by the sheer scale and integration of American carriers, that ambition was confronted by a new kind of reality: industrial and systemic superiority, an invisible weapon no pilot could shoot down, no armor could withstand. Rear Admiral Masayuki Tanaka, reflecting years later, wrote, "Our skills could craft marvels, yet the challenge was no longer technical alone. We faced a foe whose production, coordination, and standardization surpassed any single vessel we could imagine. The war had shifted from individual mastery to the scale of nations. The human cost of this realization was both subtle and pervasive. Pilots, previously trained to execute precise and daring strikes, now faced the inescapable calculus of operational constraints. A limited flight deck meant fewer aircraft could be airborne at any given moment. Fewer aircraft meant smaller strike groups, longer intervals between attacks, and diminished capacity to challenge the overwhelming presence of Essex-class carriers. In practical terms, the ability to control the skies, a critical factor in naval strategy, was irreversibly lost. Moreover, the engineers themselves bore a silent burden. Every adjustment to the elevators, every reinforcement to the flight deck, every attempt at incremental improvement was a tacit acknowledgement of systemic inferiority. They were creating a vessel that could exist and operate and even train crews, yet never achieve parity with the American benchmark. Diaries from Yokosuka's design offices from late 1944 and early 1945 reveal entries suffused with quiet resignation. One senior mechanical officer noted, "We design and calculate, we test and rebuild, yet each effort underscores the impossibility. We measure ourselves not by what we create, but by what we cannot match." The failure to replicate the Essex-class elevators was emblematic of a broader strategic reality. Japan's industrial base, already stretched by shortages of steel, fuel, and skilled labor, could not sustain simultaneous production of carriers, aircraft, and ammunition at a scale necessary to contest the Pacific. Submarine attacks on shipping lanes, aerial bombardments of factories, and depleted raw materials meant that any attempt to match American designs was not simply difficult, it was impossible. The abandoned elevators were not just steel and TT-Poret machinery, they were a symbol of systemic imbalance, a tangible measure of the industrial gulf between the two nations. Even as the war approached its catastrophic conclusion for Japan, small acts of ingenuity persisted. Shinryu II's engineering teams experimented with improved hydraulic pumps, reinforced support beams, and optimized aircraft handling protocols. Maintenance crews devised methods to cycle aircraft more efficiently despite the smaller elevators. While these adaptations could not overcome the limitations imposed by material reality, they reveal the resilience and creativity of Japanese naval personnel under extreme constraint. The operational implications of the failure to replicate the Essex-class were stark. By mid-1945, American carriers could launch waves of aircraft in synchronized strikes every 90 minutes. These operations combined radar-directed fighter sweeps, proximity-fused anti-aircraft shells, and coordinated attack vectors, an integrated system designed for maximum attrition of enemy forces while minimizing American losses. Japanese carriers, hampered by smaller elevators, slower launch cycles, and limited pilot availability, could respond only defensively. Even if pilots displayed exceptional skill, the structural and logistical limitations of their ships rendered their actions largely reactive. The abandoned elevators, in essence, redefined Japanese expectations of naval engagement. Where once decisive battles could be won through tactical brilliance or daring strikes, the balance had shifted toward industrial endurance. In war diaries and post-war memoirs, officers repeatedly acknowledged this reality. Rear Admiral Keiji Shibasaki, in correspondence preserved in the Japan Center for Naval History, wrote, "Our carriers may still fly, our pilots may still fight, yet the decisive element has become the capacity to sustain operations, to produce fleets and aircrews beyond the enemy's capacity to destroy. Here, we are no longer equal." Strategically, the episode had enduring implications. The United States' ability to produce standardized, robust carriers like the Essex-class, complete with massive elevators, rapid launch systems, and integrated operational procedures, made direct Japanese imitation futile. It highlighted the emergence of a new model of warfare, one in which victory was determined as much by national capacity, industrial engineering, and systemic integration as by individual heroism or tactical cunning. Japan's failure to match the elevators became a microcosm of this paradigm shift, a tangible manifestation of an operational principle that would define modern naval conflict. Mass production, redundancy, and system integration could outweigh individual skill. The symbolic legacy of the 5,000-ton elevators endured long after the war. In naval engineering circles, they came to represent a threshold of capability, a measure of industrial and systemic dominance rather than merely a mechanical function. Post-war analysis emphasized that replicating a single technical feature without replicating the entire operational ecosystem, trained crews, standardized maintenance, coordinated air operations, supply chains was insufficient to achieve parity. The Americans had created not just a machine, but a system in which every component, from hydraulics to radar, from pilots to ordnance crews, functioned in synchronized harmony. Japan had attempted to imitate, but only partially. The human dimension of this story also resonates in post-war memoirs. Engineers, planners, and officers who had worked on Shinryu II frequently reflected on the bittersweet nature of their accomplishments. One account, written by Lieutenant Commander Hiroshi Sakurai decades later, reads, "We created a vessel of elegance and technical refinement, yet it could never be the equal of the Essex. The lesson was humbling. Skill is finite. Resources define the bounds of possibility." These reflections underline the profound psychological impact of confronting systemic limitations, even among the most talented and dedicated personnel. Even operationally, the consequences of the failure to replicate the elevators were tangible. Japanese carriers could not achieve the same sortie rates, rapid redeployment, or sustained air operations that characterized the Essex-class. In the final campaigns of the Pacific War, Leyte Gulf, Iwo Jima, Okinawa, this disparity translated directly into losses. Japanese pilots, aircraft, and ships were consumed in attrition battles they were structurally ill-equipped to contest. The abandoned elevators, in a sense, foreshadowed the inevitability of these operational outcomes. By the war's end, the story of the failed Essex replication was preserved in engineering reports, design logs, and officer diaries. It became a case study in both technical ambition and strategic limitation. Analysts emphasized that while Japan possessed highly skilled engineers and innovative designers, the absence of a supportive industrial framework made certain ambitions impossible. The 5,000-ton elevators were thus emblematic of the larger lesson of the Pacific War. Systemic capacity, not individual brilliance, often determines strategic outcomes. In a post-war context, these lessons influenced naval design and doctrine. Japanese engineers and naval strategists, reflecting on the limitations revealed by the Essex comparison, prioritized modular designs, realistic capacity assessments, and integration of production systems with operational doctrine. The psychological and material lessons of the abandoned elevators became guiding principles for post-war naval engineering, emphasizing the interplay between technical aspiration and industrial feasibility. Ultimately, the final chapter of Japan's Essex copy project is one of paradoxical achievement and limitation. The Shinryu II, though never the equal of its inspiration, represents both the ingenuity of Japanese naval engineers and the constraints imposed by material reality. Its elevators, smaller, slower, and insufficient, stand as a symbol of ambition curtailed by industrial disparity. The narrative underscores a profound historical truth. In industrialized warfare, even the most brilliant designs require the resources, infrastructure, and systemic integration to be fully realized. The story resonates not only for its technical and operational implications, but also for its human dimension: engineers who labored under impossible constraints, officers who confronted the limits of doctrine, and pilots who flew aircraft from carriers unable to match the Essex, all experienced the collision of aspiration and reality. Their reflections, preserved in diaries and memoirs, illuminate the psychological contours of a nation forced to reconcile skill with structural impossibility. As historians have noted, the abandoned 5,000-ton elevators encapsulate a central irony of World War II naval warfare. Japan's capacity to innovate was extraordinary, yet insufficient in the face of American industrial and systemic superiority. Where tactical daring had once determined outcomes, by 1945, industrial output and operational integration dictated the course of events. The lessons of the Essex elevators thus extend beyond a single ship or fleet, offering enduring insight into the dynamics of modern conflict. In the final analysis, the Essex-class carriers did not merely outmatch Japan's designs, they reshaped the strategic, operational, and psychological landscape of the Pacific War. The 5,000-ton elevators, ambitious yet unattainable, remain a symbol of that transformation. They remind us that in the crucible of industrialized warfare, capacity defines capability, and the scale of production often outweighs even the greatest individual skill. Standing on the deck of Shinryu II decades later, Rear Admiral Tanaka would reflect, "We designed what we could, yet we confronted what we could not." The Americans had redefined the parameters of possibility. The elevators were steel and hydraulics, yes, but they were also a measure of inevitability. We labored to catch up, and in doing so, we understood the war's new rules. The abandoned Essex copy project and its emblematic 5,000-ton elevators thus remain a testament not only to technical ambition, but also to the inexorable logic of industrialized warfare, a lesson forged in steel, human labor, and the unforgiving expanses of the Pacific. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.